binomial theorem. You guys saw this last year when you were talking about binomial expansion, back with polynomials. And what we were able to do is that there's a pattern that occurs as you take binomials raised to powers. It helps us find coefficients. It helps us to FOIL things out really, really, really fast. So let's just kind of go through this here. So what we're doing here is we're going to take a binomial and raise it to some power. And as you raise this binomial, remember, binomial is something with two terms in parentheses, two parts in the parentheses. As you raise that to a power, as you FOIL and distribute and go through, certain things occur within the coefficients and with the exponents. So I kind of want to show you guys what's happening in the background as we go ahead and start looking at the actual values themselves. So let's take a generic binomial, x plus y, and raise it to the 0 power. What's anything raised to the 0 power? 1. What's anything raised to the first power? Itself. Now, when we go to square stuff, don't kill a puppy. You have to FOIL it out, remember? Remember the pattern? First term squared, last term squared, add the two together in the middle, and double it. First term squared, last term squared, multiply the two together, and double it. Eventually, it becomes easier to follow the pattern. We're doing plus right now, so all of our signs are going to be positive. Now, I'll show you the trick with the negatives here in a second. They just alternate. If I cube it, it's taking a squared term and then FOILing it out again. Do you agree? So just so we can see what this is happening, if I take x plus 2xy plus y squared, and I multiply it by an x plus y, I distribute out, sorry, I didn't mean to get too far ahead. I get an x cubed, a 2x squared y, and a xy squared, x cubed y, 2xy squared, and a y cubed. You get all that. And then we would combine our like terms, where you get x cubed squared y, which is 1. This is not supposed to be x cubed here. This is supposed to be x, y. This is supposed to be, I think I got ahead of myself here. This is x squared y. There it was. Sorry about that. It was an x squared y, not an. So that should be 3x squared y. So these two are written out. And it's going to be 3xy squared. And then we're left with the y cubed. So your tail ends are the high exponents. The middle ones, notice how actually you might see this now. Watch what happens with the coefficient, or excuse me, the powers of the x. Cubed, squared, 1, and now there is none. With the y cubed, it's us ending 3, 2, 1, nothing, so it's 0, 1, 2, 3. Your exponents decrease by 1, or your exponents increase by, or when they increase by 1 for the other one. If you want to think of it, they decrease in different directions, working them way out. Let me show you what happens with the fourth. Are you guys okay with x plus y to the fourth would be junk squared plus, or times junk squared? Yeah. So if I FOIL that out twice, I would get this. Move this up. get x to the fourth, 2x cubed y, x squared y squared, plus 2x cubed y plus 4x squared y squared plus 2xy cubed plus x squared y squared plus 2xy cubed plus y to the fourth. And I think I got them all.
I'll just go with it.
Combine your stuff. We know we have an x to the fourth. X cubed. So I have 4x cubed. X squared. We have 1 here, 4 here. Gone. 2xy cubed. Oh, did I skip? I've skipped an xy squared. Sorry, so this should be 6. So look at your exponents again. Notice what's happening with the x's exponent. 4, 3, 2, 1, nothing. Look at the y's. Nothing. 1, 2, 3, 4. What do you think the exponents are going to look like for the fifth power?
Go 5, 4, 3,
5, 4, 3, 2, 1, nothing, and then nothing, 1, 2, 3, 4, 5.
Yeah.
That's pretty snap.
Wait, wouldn't?
Do they just double?
What do you mean nothing? Wouldn't nothing be the one?
So it doesn't go x.
And it would be x to the fifth, and then it would be x to the fourth, y, x cubed, y squared, x squared, y cubed, x, y to the fourth, y to the fifth. That's what the exponents would be doing with variables. Now the coefficients are going to be different. Coefficients are going to be different. That is dependent upon the numbers that preceded it. You guys ever heard of a thing called Pascal's triangle?
Yes.
Yeah.
That's where this comes from.
Do I write it down again?
Pascal's triangle? Did you write it down before? Where you had 1, 1, 2,
Yeah.
1.
Yeah.
That just
I
gets-
just like do it on a test, like.
Yeah.
I messed it up.
Well, you can do it on a test, or you can actually, there's actually a way
Write
to.
a whole thing out on one.
Oh, that's
We had to
crazy.
go like,
Yeah.
do like 5.
Yeah, but you know what? It's, if you go through the pattern on it, it's not that bad.
I like got confused what was supposed to, because like I couldn't make it straight, so I got so confused like what something was.
What happens here is that all you're getting is your coefficients. Your coefficients come from a triangle. Going through the triangles, these are ones coming down all the way here. These are ones on the outer edge. It started with a 1. What's 1 plus 1?
1 plus 1 is
2. What's 1 plus 2?
3.
And then this one, 2 plus 1 is 3. 1 plus 1 is 4. 6, 4. Here we get 5, 10, 10, 5. See what's happening? You're taking the triangle and the outer edges are 1s.
Just adding 4.
Each one between them is the sum of the two numbers above it. It's kind of crazy how it works. You start with 1 up top, then you get 1s on the edges. 1 plus 1 is 2. 1's on the edge. 1, 2 drops to a 3. 2, 1 drops to a 3. So you're getting all of these to keep coming through. Okay? That's how the coefficients work. Or you can use the button on your calculator.
I like that.
Because if you have like a polynomial that has a degree, let's say that's above 5, then it starts to become really, really tedious to write all of this out. And you guys can attest to that if you had to write it out before. It's not terribly difficult to do, but if you're not careful with putting things in order and stuff and making everything straight across, it can get pretty cumbersome. So you actually have this binomial theorem way of writing out the coefficients, and it has to deal with combinations. The coefficients, you can come up with this. excuse me. What happens in the middle of the binomial theorem is that your first term always has a coefficient of 1. Your last term always has a coefficient of 1. Always. Now your next term is always going to be whatever the coefficient is. Whatever your exponent was. So if it was a squared term, the second term of the sequence would have a coefficient of 2. If it was a cube, it would be a 3, and so on and so on. But what happens in the weird part in the middle, is you can use this combination, the NCR, N choose R. There's a button on your calculator that'll do that for you. Or, if you remember what that means, you can simplify it rather quickly. Okay. Now, what happens here is if you're using factorials. You guys remember what factorial did?
Yeah.
What would 5 factorial be?
5 times 4 times 3 times 2 times 1.
So if I wanted to, don't write all this out. Let me show you an example of how we're going to do this here in a second. If I wanted to say that we had 8 choose 3, this would have been.
Oh, is this where we did that?
Yeah, a little bit of that.
Are we gonna play cards? I told my mom that we were going to, so I hope that we did. Because she thought it would be fun.
What's 8 minus 3?
She goes, sorry guys, can we play cards?
8 minus 3 is
What's 8 minus 3?
8 minus
5. 5 factorial would be, and then 3 factorial would be, and
Cross stuff out.
then you start crossing stuff out. So what you're able to do, 5, 4, 3, 2, 1, 5, 4, 3, 2, 1. And what's 3 times 2?
6.
So 6 goes away. So 8,
No, what do you say?
8 choose 3 if you will, or 8C3. Your answer is going to be 8 times 7, which is 56. Okay. That's what happens. There is a button on your calculator that does that for you. So you don't have to crank it out by hand. It's just sometimes quicker to do it that way. That's all. So let's see. These guys believe it is.
Oh, yeah, I don't know how to do it on
What is it? It's under. I think it's under probability. Is it 3? Oh, did I hit the wrong button?
We're trying to figure it out, okay? Ooh, you hit menu and you hit 5.
Yeah.
And you hit 3.
Yeah. I think if you 8 comma 3, I believe.
I don't know where the comma is.
Oh, there it is.
It's on the left.
There you go. So in this calculator, in order to do the NCR button, you would hit the menu, and then you would hit 5 for probability. I think everybody has that for option 5. And then choose combination. And it should show up NCR parentheses. You have to tell it what you're choosing. 8 of them, comma, 3, and it does the calculation for you. Everybody all right with that? Now, there's a couple of ways that the book will write this out. The book will write it out.
Wait, can you go over what you pushed?
What?
Push menu, then.
Yeah, I'm sorry. I'll do that again for you. Hit menu, 5, 3.
Oh, okay.
And then it'll just be 8, comma 3.
Okay.
And you know where the comma button is, right?
I'm looking, found it.
Bottom left.
Yep, got it. Thank you.
So, like I said, the book will write it out a couple different ways. It'll write it out with like this, or it'll say 8, 3 in parentheses, like that. It means the same thing. Okay?
That's all.
Yeah, it means the exact same thing.
Oh,
Time flies when you're having fun.
we're having so much fun. So much.
Don't mind.
I'm not.
Yeah.
But I'm,
Oh, Mr. Murphy, I showed the video to my sister. And she's like, no way, Mr. Murphy looks the same. So my sister was like, Mr. Murphy has hair.
It's not like I never didn't have hairs.
That's what I always thought. Like, I just think her hair like this.
Do you know why he doesn't have hair? One time,
if your mom had that conversation,
and he said this is what happened.
Jack told me to do.
He said that it went.
Oh, you did.
Oh, no.
So like.
Oh, this
So then it's just like. Went
Why
like
no?
this, and then, like, it just didn't.
All right. So let's take a binomial raised to an upper degree. And what I want to do first is space it out enough so that way we can figure out all of our coefficients. So let's write out the variables and their exponents first. Since it's a 7th degree one, we know it's going to be an x to the 7th, and it's going to end with a y to the 7th. It's going to be plus between all these because I kept that sign there. So for right now, I'm just going to say I know it's going to be plus. I'm going to put a little blank here. X to the 6th, y to the 1st. You okay with that? I'm running out of space rather quickly. I got to write a little bit smaller. Sorry.
Oh, shoot. I'm ready, so it's.
Remember, your exponent should always add up to equal whatever your power is up top.
Can't really tell that.
Well, we know the coefficient here is 1. We okay with that?
My first line was way too big.
Are you okay with the exponent, the rules of the exponent? 7, 6, 5, 4, 3, 2, 1, 0, 0, 1, 2, 3, 4, 5, 6, 7. You got that much down? Everything else is a piece of cake. All right, everything else is going to be really, really easy. Because what happens here for our exponents then, for our coefficients, is that we have 7. So our first coefficient here would have been 7, choose 1. 7, choose 2. 7, choose 3. 7, choose 4. 7, choose 5. 7, choose 6. 7, choose 7. I think I skipped one somehow. Why did I skip that? Because it's supposed to end in the 1.
Do you skip the first one or the last one?
No, we shouldn't have. I screwed up. Because it's supposed to end in 1 and finish out in 1. I screwed up. So this is. You know what? I forgot what I messed up here. Let's worry about your day 1 stuff is only getting you up to about here anyway, about writing out this. We'll worry about our coefficients, setting up the coefficients, and I'll show you the tricks for that tomorrow then. No, we'll worry on the coefficients tomorrow, because I think I skipped a line on our choose things for some stupid reason. Oh, I know what it was. It's 7, choose 0. Starts at 0. That's why. Sorry about that. That's what it'll do. Those are how your coefficients are going to line themselves out. You start at 0 and you go through your exponent, because you're going to have, if you put those in the calculator, if you're doing 7, choose 0, all right, the calculator. As you go through this, you'll start to see you're going to get 1, 7, 21, 35, 35, and guess what's going to happen? 21, 7, and 1. These values here are always going to be that multiplier that goes in front of the coefficients. So when we get to the point where we have not just a binomial of x plus y quantity to the 7th, we might have 3x plus 2y to the quantity 7th power. Then we know that we're going to have to take these values and multiply them by whatever the coefficients are in here as well. Okay? That's how we get this stuff started on. We'll continue working through this stuff tomorrow, and then build out.
Page 3 through 54 every third.
Yeah, 3 through, so day 1 is
3 through 54 every third.
So for the homework, it was like something for 92.
Did you take 92? Oh, no, you're involved.
I'm in your same class.
Today was 10, right? Are you
Turn away. Are you taking the 8-push one?
Oh, the acronym of
Say
that.
oh no, it's 48 through 92 by 3. So you go 48, and then it's going to be 51.
My mom wasted
Oh, you're
100
right.
bucks last year on a euro.
I didn't write it. As you can see, it wasn't me that wrote it. It would have been some other math teacher. Not me.
Not you.
I'm not calling anybody out.
So I had all these other tests.
What's up?
Can
you help me with the problem in the worksheet?
Yeah.
I knew I didn't, but I wasn't